In this segment, we're going to look at using Excel to evaluate and analyze bonds. We're going to look at pricing them. We're going to look at yield to maturity, and calculating that and the yield. I've set the spreadsheet up so that in the gold area, you'll see the three values that define a bond. Remember par value. Par value is the amount of the loan. In most cases, it's $1,000. The coupon rate, that's the percentage of the par value that will get paid out in interest every year. Important to start thinking about this. This bond will pay interest rates twice a year. Those payments will be made twice a year. So coupon rate of 8% would be $80 a year, but it gets paid twice. So it's $40 in each installment every year. Maturity. This is the number of years to maturity. But remember, we're getting paid twice a year. So when we calculate our present value, we're going to actually modify this number. Now, the required rate of return is what I, the investor, need. This is different typically than the coupon rate. Coupon rate is what the issuer, the company or the state or the city had to pay in order to get somebody to buy their bond. This is what I want. I'm the investor. I'm going to buy this sucker up here in gold. But I require 9%. Given my opportunity costs, I'm not investing unless I can make 9%. All right. So these are the things. I've also named these cells. Look here. You can see it says par value and coupon rate. I've named these cells so that when we do these equations, it'll be easy to see what they are. All right. First one to calculate is the price of a bond. This is also the value of a bond. And this is also how much we're willing to pay for a bond. How much are we willing to pay? Well, that's the price. Anytime we talk about willingness to pay, the value or the price, we're always talking present value. It's the amount we would pay today for this bond. Remember, this bond pays stuff out for 10 years. What is it worth to me today? If I want to know what it's worth to me today, that's always a present value. Remember in the last segment, we talked about the calculation was that bond is the present value of future payments. So let's find out the value of this bond here. Well, the value of this bond, first is the rate. That's the required rate of return. So here I'm going to put the required rate of return, except, now this is very, very important. Don't miss this. This bond pays interest payments twice a year. Well, my required rate of return is expressed as an annual rate. If I'm getting paid twice a year, then in each of those periods, every 6 months, I only need half of my annual required rate of return. My required rate of return was annual, but since I'm getting paid every 6 months, I only need half of that. So I'm going to divide by 2. Number of periods. Well, it certainly is the maturity, but remember, it's twice as many periods because I get paid twice a year. So here I multiply by 2. Right. What is my payment? That's the next thing I want to know, my payment. Well, it's my coupon rate, right? 8% times my par value divided by 2. Because I get half each period. And finally, my future value, which I'm trying to get next, is just my par value. And that calculates the present value of that bond. Let me go over this one more. Oh, let me just calculate this. Now, it's a negative number, right? Because I'm willing to pay it, and I get those values. If you don't like the negative, just put a negative in front of the formula. Let me show you the formula next to it. So there's the formula. Let me go over it one more time because this is important to get all the divide by 2's and the times 2's correct. My rate of return, I have to divide by 2. If I'm getting paid twice a year, everything gets divided by 2. If I get paid once a year, then it doesn't matter. If I get paid 4 times a year, then it's, instead of 2's, I put 4's in here. So my required rate of return is not the 9%, but it's that 9% divided by 2. That's because I'm only dealing with 6 months periods, not a year. My maturity is 100 times 2 because I am dealing with 6-month periods. So I have twice as many periods as years. My payments are my coupon rate times the par value, but I get half of those each time. I get paid twice a year, so I divide by 2. And in the future, I get my par value. This is probably the trickiest thing for people to get this equation, to understand this. It's very important. Again, if I was just getting paid my coupon once a year, then I would not do any of these. So let's just do that too. So if I'm getting paid once a year, if I'm getting paid once a year, I'd get rid of that, get rid of that, and get rid of that. Now I'm getting paid once a year. And it changes my present value. But let's go back and see what happens. So notice one thing that happened. We talked last time about if the required rate of interest goes above the coupon rate, the price of a bond went down. Notice that's what happened. I require 9%, but the coupon is only 8%. So I'm not willing to pay as much for the bond. I'm only willing to pay $934.96 for a par value $1,000 bond. If my required rate of return goes to, say, 4%, much less, right? I should be willing to pay more. And indeed, I pay $13.27 3 cents. Why? Because this bond pays a whole lot better interest than I require. So I'm willing to pay more. These are kind of important things to do when you do these kinds of formulas, is to take a look at these and see if they make sense. Are they making sense? If this number came out to be less, you'd say, well, that's not right. Here's another thing we can check. Let's suppose I need 8%. I require $1,000. Right? Because my required rate of return is equal to coupon rate, so I'd be willing to pay $1,000 for that bond. These are kinds of things you can do to check your work, and I highly recommend looking at it, just giving an eyeball test. Because if this ends up being $25 or $2 million, or the sign is wrong, you know that you got to look at your formula. Something's wrong. All right, so I hope that was okay. Yield to maturity. We'll cover that and the others in the next segment.